How much cake am I gonna eat? If I can't finish this video by the time I eat the cake, we're done. Good coffee. Well, hello, computer nerds. Nice to see you. Well, we're here for the second video of our first project, Planetary Defense version 2. And let's sort of recap what we did last time. Last time we talked about the project, what kind of scope and scale we wanted to do. We had a nice brainstorm session talking about what we liked about the game, what needs to be improved, some enemy options and some ammo options and bonus ups and stuff like that. And then at the end we wrapped it up with like a short list of all the things that we must implement so that we can get a functioning game to play around with and add enhancements to. And so we're going to do those starting items so that we do have a functioning system for us to work on. And we're also going to talk about game engines. Because the nice thing about programming today, instead of in the 80s, is all of these developers have made these wonderful gaming engines that we can use. So it takes care of a lot of the legwork and muscle of moving data around and sprites and rendering, and it's just really easy. So we're going to talk about that. Now there's lots of game engines out there, and we could pick the latest and the greatest, or something that's more defined for something that we're developing. But we're going to use Unity because I'm familiar with Unity. I've done a lot of stuff with it, and I really recommend that if you're going to work on a project, that you use a tool that you know. Don't spend the project time being your training time learning a new tool. If your project requires a new tool, find someone who's an expert in that tool and use them. You don't want to put the project at risk because you're unfamiliar with a tool and you're not sure if it's going to do what you need to do. Do your training on your own time, and put the risk on the design aspect, not the coding aspect, and you'll be much happier. We're also going to do a little bit of math, sort of explaining the 3D and 2D options and screen resolutions and ratios and things like that, because when we're working on this, we're going to have our play field, and it's going to be sort of virtualized, as in it's not going to be based exactly on our screen's pixels. It's going to be based on the ratio of the viewport and whatever resolution we decide to have our sprites at. So we'll talk about that. There's also a couple other brainstorming things that popped up, so we'll talk a little bit about that. And so we'll do the basics, get the starting system going, and then we'll critique it. So we'll have something to fix if necessary. The whole idea is that you make it functional, you critique it, improve whatever you can during that aspect of it, and then move on to the next set of features. You sort of look at the features and you decide how much time is it going to take to do this. Is it worth doing this now? Should I do it later? And come up with like a bullet list of what you're going to do for the following week. I'm not going to talk much about Agile and Scrum Scrum projects and stuff like that, but we're sort of following some of those ideas just to make it interesting. So I got my coffee, I'm the programmer. Let's put some gears on and make some code. Okay, I'm going to switch over to the eye in the sky camera, and we'll start talking about 3D modeling, 3D game engines, that is. All right, bye. Okay, I think I got all the notes that we're going to need for this part. And we're going to start off with the brainstorming. Now, normally when you working on a project, you don't like to add features, but we're still, in the early phases of the project, so I don't think it's a terrible thing to add a few more features. But also, brainstorming should be available for, little enhancements and tweaking. So when I was talking about missile command the other day, I kind of talked about how silly it would be to have jet fighters in space. But I got to thinking about it, and you couldn't have jet fighters, but you could have, spaceships, space rockets. And so I think we should add that as one of the either good guys or bad guys. Have a space rocket with some classical, 50s bubble cockpit, and it could fly in and drop off some bombs or bullets or missiles or whatever, or ammo, whatever could be good. The other thing I was thinking about was our bullets right now are designed to be fired off, and they either hit something and blow up, or they just go off the screen and don't do anything. But I was thinking about how Missile Command does it. They have rockets that can shoot up, and when they get to a particular spot, they blow up in a flak cloud. I think we can do the same thing in Planetary Defense. So instead of a bullet, we could also have rockets for a possible bullet. And another way for us to get this, I was thinking that they could be part of the ammo containers. We could have different types of featured ammo in these containers, and so you have to carefully watch them and let them land on the planet to collect that particular power-up. And then you can switch between the bullets and the extra ammo or landmines or whatever you want throughout the game. So that's it for the update on the brainstorming. I think we could eventually come up with a backlog list of features we want to add to the system, but for now, I think the brainstorming list is working okay. Okay, so let's talk about how 3D engines display stuff on the screen. And it all has to do with perspective. So we'll talk about the 3D perspective. And this is a diagram of it. At the very tip is our virtual eye that's viewing the 3D space. Sometimes it's called the camera. But the perspective lines coming out of that spot create the visible area of the screen. Now, if we have a 3D object, the same 3D object in two different spaces, one up front and another one in the back, up in the top. When the system tries to figure out how to display it on the viewport, it will draw the line from the perspective point to the screen and make the representation flat so it can be viewed. But depending on how far it is, will determine the size of the object, right? So if I take a ruler here and draw straight lines from the eye to the 3D object, you can see that's the bottom part, and then that's the top part, and that gives you the size of that object. And then for this object, see, that's pretty close, and that's also pretty close. So you can see that the closer the object is, the larger it shows up on your screen. And so that's kind of the basic idea about how it works. You can have objects move around in the space, and as long as it shows up inside the viewable area, it'll show up on the screen. If it's outside of that area, it won't show up. Okay, so your screen is actually based on your monitor size. But in the virtual space, it's all based on units. So this is what we call the fulcrum, the visibility fulcrum. A fulcrum is pretty much a pyramid with the top cut off. But this fulcrum with the min distance and the max distance, it tells us the viewable area of the world. Now we can have objects in front of the viewport and they won't show up. We can have objects outside the fulcrum and they won't show up. It has to be inside the fulcrum to show up. Now you can still have objects moving all around, but until they pass into the fulcrum, they won't get displayed. All right, so that's how they do 3D. Now, how do they do 2D in Unity? Is they still have the eye, and they still have the screen, right? And the screen is based on the monitor size. But they also have the viewport, and they also have the max distance. And the thing is, it's all the same. So this playfield area, I just picked an arbitrary spot like z equals 100. And the playfield screen is like at 0. And it has a width and a height, which is its display view. But it's not as important for the game because the game is just working on these ratio units. And as long as the screen is matching the ratio units, it'll work out the same. So the viewport here, or actually the playfield, needs to match the screen's ratio. And as long as that happens, everything will be nice and smooth. So we can have objects at any z position, and when it gets rendered onto the viewport, it will show up at the same perspective, the same ratio, no perspective at all. And so the z doesn't matter, but it can help like organize what sprites show up in front of other sprites. But generally what I do is I'm going to have everything on the same z position, and everything will show up nice and smoothly. So what we need to do is we need to talk about the ratio and how to calculate our sprites so that everything will match up as we're putting them onto the playfield. Okay, so let's take a look at different screen sizes. All right. So up at the top here, this is my monitor's screen size, and it's 1280 by 1080. No, it's 1980 by 1080. And if I do the ratio here, I get 16 by 9. All right. And so that's just taking the top and dividing it by, or taking the height and dividing it by the width. Now the playfield area, I just need to make sure that it matches this 16 by 9. And so I picked the 1280 by 786. And if I take the 1280 and I divide it by 16, because that's the number of units across that the screen is, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 15, 16. Okay. That works out to 80 pixels per unit, or 80 pixels per inch. So whenever I create a sprite for the playfield, I need to make sure its resolution is 80 pixels per inch. And that way, all of the sprites will look the same and match up. And it doesn't matter what the screen size is going to be. As long as it matches up, it'll look good. If I don't match it up, it's going to start looking kind of wonky, right? Where some things look out of place and bigger. And as a matter of fact, it doesn't matter what the screen size is, as long as it's hitting the ratio. Okay, so let's take a look at some of the other devices that are out there. iPads are doing a 4:3 ratio, which is very similar to the old style TVs and arcade machines and CRTs. Now, if I multiply both sides by 4, that gives me a 16:12 ratio. And what that means is the playfield will have a blank line at the top and the bottom, that whole letterbox format, right? But the game will still play, so everything should be fine. Now, iPhones, with all the different sizes that they have and all the different resolutions, they are still 16:9, which is the same as like a computer monitor, which is pretty good. It's also the same as like TV monitors as well. And it has that 1080. So that's pretty amazing that as long as it's matching that 16:9, it'll look great on that system as well. You know, the resolutions of the iPhones are just outrageous. They got super high resolutions, but as long as it matches this ratio, everything's fine. So we know we can start by working on our art assets, making sure that they match this playfield, and set them at 80 pixels per inch, and we should be good to go. Okay, so let's take a look at Unity, and we'll show you the starting features and see how things are. Okay. More coffee. All right. So now it's time to show the progress we've made so far in the game. And we're going to switch here to Unity. Now, these videos aren't going to show you how to use Unity. It's not a training video. If you want to learn how to program in Unity, go to Unity's website. They have wonderful tutorials and lots of examples. Or go to one of those training websites that really specializes for online and coding kind of things, like udemy.com. I bet they have some really good lessons in there. But this is the Unity interface. This is sort of the scene design, and then this is what the camera sees. So I'm just going to run this here, and it has the main things that we said we needed to have is the planet in the center, and the satellite going around the outside, and then we have our target here, which is controlled by the mouse. So it's very responsive, and you know, you can point very accurately, and of course firing bullets. And what happens is when you fire a bullet, it goes to the, you know, right through the center of the target. Really accurate. That's really nice. And of course, we don't have any limits on the ammo at this point. That's something we'll have to do in the future. We also don't have any slowdown. It's doing 1 bullet per frame. So, you know, this is cool, pretty impressive. But it's not going to work if we have limited ammo. You're going to shoot off your entire ammo with one single push of the button. Critiquing, what do we need to do? Well, obviously, the graphics right now, we're just doing working graphics. We'll have a whole section on graphics and artwork and making it all follow a theme. So we're not going to concern ourselves too much with artwork. But the size of the planet is about 1/3 of the screen. You know, if you consider you can have like score and stuff down here and maybe little messages down here. And so that's okay. The satellite may be a little too large. We might have to shrink that down. The cursor looks pretty good size, and the bullets seem to go at a pretty good rate. But what we do need to do is we need to slow down the rate of bullets. So I'm going to write this down. Slow down bullet rate. The mouse seems to be pretty responsive here. The planet seems to be pretty good size. So other than that, I think it's pretty good. But what you may have noticed here is, you know, I'm shooting through the planet. There's no collision detection. So that's definitely something we need to add, is collision detection. And that's going to be a big piece. We'll probably dedicate that all to the next video. I think the other thing we should do is we should like set up little bullseyes as little targets for us to practice creating enemies. So we'll do bullseye targets. They won't have any of the intelligence of moving and scoring or anything like that. We're just going to have it there for us to shoot at. And also when it hits something, we'll have to make the explosions for when the bullets hit something. Okay, so let's write that down too, explosions. And I think that's enough for next time. All right, so here we go. Slow down bullet rate, do collision detection, we'll do some bullseye targets, and some explosions. All right, that's what we'll do next time. Thank you very much for watching through this whole video. I hope you like it, and we'll check you on the next one. All right, thank you much.